Okay, we move to the next subtopic, which is the factor theorem. If the remainder obtained from dividing the polynomial px by x minus a is 0, then the linear terms x minus a is called a factor of the polynomial px. Okay, if pa is equal to 0, then x minus a is a factor of px. We have a note here. Conversely, if x minus a is a factor of px, then pa should equal to 0. Okay, in general, if ax plus b is a factor of px, then p negative b over a is equal to 0. Okay, let's see the first example. Determine whether the following linear function are factors of the given polynomials. Okay, we are given x minus 3. So, we just substitute here when x is equal to 3. So, on the right hand side, 3 minus 21 plus 45 minus 27. What is the answer? So, here we have the answer is equal to 0. So, now we have P3 equal to 0. Okay, if we have the answer is 0, means that, okay, therefore, x minus 3 is a factor of the px. Okay, make sure you write the conclusion. Okay, let's see question B. We want to determine whether the given linear to x minus 1 is a factor of the polynomial. Okay, now, okay, what should we substitute the value of x? Okay, the linear is to x minus 1. So, x should be 1 over 2. Okay, so substitute here. On the right hand side, the value of x with 1 over 2. So, we have here 2 times 1 over 8 plus 3 times 1 over 4 minus 8 times 1 over 2 plus 3. Okay, what is the answer? Okay, the answer here we have equal to 0. So, P 1 over 2 is equal to 0. Means that, okay, we will write the conclusion. Therefore, 2x minus 1 is a factor of the given polynomial px. Okay, example 3. We are given px equal to x power 4 minus 2x power 3 plus 3x minus 6. And we want to determine whether x plus 1 is a factor of the given polynomial. So, substitute p negative 1 is equal to, okay, the right hand side is 1 plus 2 minus 3 minus 6. So, what is the answer? The answer is negative 6. Okay, so since we have a remainder here, not 0. Okay, so the conclusion is, therefore, x plus 1 is not a factor of the given px. Okay, second example for factor theorem. If 2x plus 1 is a factor of polynomial px, find the values of p. Okay, we are given that 2x plus 1 is a factor of px. So, firstly, we need to rewrite p negative 1 over 2 is equal to 0. Then, substitute x equal to negative 1 over 2 into the given polynomial. So, we have here 2 times negative 1 over 8 plus p times 1 over 2 minus 5 equal to 0. Can you find the value of p? Okay, please find the value of p by yourself. Third example. Given that the expression 3x power 3 plus ax square plus bx minus 12 is exactly divisible by x square plus 2x minus 3. Okay, exactly divisible. Okay, means the remainder is 0. Okay, A, determine the values of A and B. B, factorize the expression completely. Okay, we are given the divisor is x square plus 2x minus 3, means our dx is x square plus 2x minus 3. This is quadratic. Can we factorize? If we factorize, we should have x plus 3, x minus 1. Is it right? Okay. We are given that px is exactly divisible by the given divisor. Means that when we divide px with x plus 3, the remainder should be 0. Okay, so here we have p negative 3 equal to 0. Okay, so firstly, substitute when x is equal to negative 3 into the given polynomial. So we have here 3 times negative 27 plus 9a minus plus 9a. Okay, minus 3b minus 12. Okay, this is equal to 0. So simplify, we have here. Okay, so simplify here. We have here 9a minus 3b is equal to 93. Okay, if we simplify, divide by 3, we have here 3a minus b equal to 31. This is our first equation. Okay, next, when we divide the polynomial by x minus 1. Okay, so we should have here p1 is equal to 0 because the polynomial is exactly divisible by px. So we will substitute px. We will substitute x equal to 1 into the given px. Okay, here we have 3 plus a plus b minus 12 equal to 0. So we should have here a plus b equal to 9. Is it right? Okay, this is our second equation. So to find the value of a and b, we need to solve the simultaneous equation, equation number 1 and equation number 2. Okay, let's say here, I will write the equation number 1 here. Okay, 3a minus b equal to 31. Okay, so by adding equation number 1 and equation number 2, we have here 4a is equal to 40 and a is equal to 10. Can you find the value of b? Okay, please find the value of b by yourself by substituting a equal to 10 into the first equation or second equation. Okay, what is the value of a? Sorry, what is the value of b? b is negative 1. Okay, this is the answer for question part A. Okay, we move to the question of part B. Part B, we need to factorize the expression completely. Okay, part B, we want to factorize the expression completely. Okay, just now in part A, we already have the value of A and B. So substitute the value of A and B into the px. Then we have here px is equal to 3x power 3 plus 10x square minus b minus 12. Okay, Okay, to factorize the expression completely, we need to rewrite into general form of polynomial, which is px is equal to qx times dx plus rx. Okay, so substitute what is px. Here we have here 3x power 3 plus ax square. Sorry, a is 10 plus 10 x square minus b minus 12 equal to qx. We do not know what is qx. We need to find the qx. And we know the dx. dx given is x square plus 2x minus 3. And if we factorize is x plus 3 minus 1. So I write the in terms of quadratic expression first. So dx is x square plus 2x minus 3. Rx, remainder. Do we have remainder? Okay, the remainder should be 0. No remainder because the expression is exactly divisible by the given dx. Okay, from here. Okay, we want to factorize completely. Before we can factorize, okay, we should look here, which is on the left hand side, we have the highest degree is x power 3. Okay, qx we still do not know what is the equation, and we know that the divisor is x power 2. So the left and the right hand side should be equal. Okay, so x power 2 times x power 1 here, so that it can be x power 3. Okay, this one, this method we call it as comparing method. Okay, so to make it the right hand side x power 3, okay, the highest degree is x power 3, so qx should be in linear expression, which is, okay, let's say I use mx plus n, okay, multiply with x square plus 2x minus 3. Okay, if we expand here, we should have the answer exactly as the left hand side. Okay, value of b, just now we have 1, right? Okay, minus 12. Okay, so from here, okay, let's look. What should be the value of the value of m and n? Okay, here, constant on the left hand side is negative 12. So, to find constant, n times negative 3, we should have constant. Okay, and if we compare here by using comparing method, okay, constant. Okay, negative 12 on the left hand side should be equal to n times negative 3. So negative 3n. Can we find what is n? N is equal to 4, is it right? Okay, so how can we find m? Okay, here we have mx. mx, if we multiply with x power 2, so we have mx power 3, right? mx power 3, the highest degree is 3. So we will compare with the highest degree of 3 in the left hand side. So we compare here x power 3. Okay, on the left hand side we have 3. So 3x cubed. So on the right hand side, mx times x square is mx cubed. So from here we know that 3 is equal to m. Okay, now we already have the value m and n. So substitute back into the expression of qx here. So we have here 3x power 3 minus 10x square, okay, minus x minus 12 is equal to, okay, mx plus n. So what is m? M is 3x, n is 4, so plus 4 times the divisor given x square plus 2x minus 3. Okay, this is not a complete factorize because we still can factorize the quadratic expression here. So final answer should be 3x power 3 minus 10x square minus x minus 12 equal to 3x plus 4 times x plus 3 times x minus 1. Okay, so this is our completely factorized. Okay, and this is the final answer. Okay, to solve question B, actually we have the other method. Okay, how can we factorize completely the given polynomial px? Okay, all we need to do is just do a long division. Okay, we are given px is equal to 3x power 3 plus 10x square minus x minus 12, and the divisor we know we are given as x square plus 2x minus 3. Okay, by using a long division, okay, px divided by dx, so we have here, okay, px is 3x cubed plus 10x square minus x minus 12, okay, divided by dx, which is x square plus 2x minus 3. Okay, by perform a long division, okay, x square times what here equal to 3x power 3. So we know that times x square times 3, x is 3x power 3. So 3x times 2x is 6x square. 3x times negative 3 is negative 9x. Okay, subtract. So we have here is 0, 10 minus 6 is 4x square, negative 1 minus 9 is 8x, and then bring down negative 12. Okay, so we can proceed. Okay, x square times what here equal to 4x square. Okay, we know that x square times positive 4 is 4x square. Okay, 4 times 2x is 8x. 4 times negative 3 is negative 12. So, subtract. We have here the remainder is 0. Okay, as usual, after a procedure, a long division, we need to rewrite the equation into the general form. The general form should be px is equal to qx times dx plus rx. Okay, so just substitute what is px. Here we have here 3x power 3 plus 10x square minus x minus 12 is equal to, okay, what is qx? Okay, this is qx. Okay, just substitute 3x plus 4. The divisor given is x square plus 2x minus 3, and no remainder is 0. So we want to factorize completely. Okay, here quadratic. Okay, so we need to factorize. It will be here 3x plus 4 times, okay, factorize x minus 1 times x plus 3. Okay, this is our final answer, and the other method, how can we find qx, okay, and factorize the expression completely.